Hey everyone, today we'll be going over graphs today. Particularly we will be focusing on building our header file for our unweighted graph, and without any further hesitation, let's get started. And now we're going to be going over our weighted graph now. First thing that we're going to do to be able to print out our necessary behaviors for our unweighted graph is that we are going to do the following. We're going to create a header file like we did before, and this time we're going to call this unweighted graph printer. I'm going to put this in column for practice, create it. And what I'm going to do now is that we are going to include our libraries. Then we will define our class. And inside of our class, we need to define a public instance. And we are going to have a series of functions. Really, we're going to have 1, 2. So we will have 1, 2, 3 functions in total, which we will have one for printing the graph, and we're going to have 2 private functions. So that way there's no miscalling between when we are putting it inside of our main C++ file, which int main here, and return 0 just for clarification. And our 2 private functions are going to render the graph, and we will also draw the arrows. Now mind you, always know this is also a directed graph whenever we are drawing arrows, and when we are not drawing arrows, it's considered an undirected graph. So like what we did before, but we're just doing this for the sake of getting fully accustomed with the C++ syntax so you can code along as well, and we know our full structure entirely. So what we will be doing to include our libraries, we are going to have 1, 2, 3, 4, 5, 6. Include, 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 include. We're gonna have iOS stream. Depending on your IDE, it will be totally different. Then we will have vector. Then we are going to have list. Then we are going to have CMath. Then we are going to have string. And then finally an unordered map. We're going to define our class. We're going to call it, and also don't forget, using namespace std so that we're not using std in multiple instances. And now we're going to have our class called unweighted graph printer. Here we go. Then right here, and have our semicolon. Then we're going to define a public instance right here, public. Then we're going to have our function for printing out the graph. So I'm going to go void print graph, and putting in our vector, because we're going to have our adjacency list of integers in order for us to be able to print out our graph. Constant here. And then what I'm going to be doing is that we're going to output our graph adjacency list. And L, there we go. In fact, I'll just zoom out a little bit so that we can see everything. There we go. Then we're going to scan through our adjacency list for int v is equal to 0. V is less than the adjacency list size. And we're going to implement, we're going to go through each vertex inside of our adjacency list to be able to output our graph. And we are going to output each vertex accordingly with the respective arrow to highlight the connectivity between the 2 vertices. We're going to have another for auto loop, auto it indicating for iterator, and we're going to be going for the specific vertex inside at the beginning, and then while the iterator is not at the very end of the adjacency list, we're going to keep implementing and incrementing our iterator. count, so that way we can know exactly when we hit the very end. And then we're gonna have count and L, and then count and L, to then output count. We're gonna implement the drawing of our graph edges using ASCII here and L, and then we're gonna do render graph with our adjacency list implemented inside. Now we're gonna have two private functions, so we're gonna call this private. I'm gonna have this function void render graph that we did over here. Then we're gonna implement our adjacency list by using constant vector list int and adjacency for constant. And since we are going to be making this graph correspond with each of the edges and vertices accordingly, we're going to put this as a radius. We're going to have a radius of 10 and then a diameter 2 times radius plus 1, and then we're going to have a vector of strings to indicate for the graph lines, putting it in for diameter string diameter times 2, and putting in each space, and then we're gonna initialize our size based on the adjacency list. So what we did is that we created a vector of strings called graph lines that's going to implement our diameter and the string, and it's going to also have a radius at the same time with respect to the size of our adjacency list eventually. Then we are going to have an unordered map to indicate the key pair values because we have an edge and a vertex accordingly. So we have int pair int indicating for the positions, and for int I is equal to 0, I is less than the size, and we increment I accordingly. Then we are going to consider our angle, double angle, equal 2.0 times m underscore pi times I divided by the size. So we know exactly the specific position when we are outputting, and we're going to have our x-axis equal radius plus the static cast int for radius times cosine angle, and then we will do the same thing for our y. Make sure you're spelling everything correctly. Yep. Now we are going to replace this with y, static cast int radius sine angle, and then we will have the positions of I within our adjacency list with respect to the x and y axis as well. Then we're going to have a for loop to indicate where specifically the vertices are going to go. So we're going to have for int v is equal to 0, v is less than the size, and we increment each vertex until we reach the very end of our adjacency list, hence size, which was called upon before over here. And then we're going to have auto x and y equal positions for each vertex that we have, graph lines of y with x times 2 equal our initial right there. Graph lines with y with respect to x times 2 plus 1 equal 0 plus v 4 into v is equal to 0. V is less than size, and we're going to come in v as well. And 4 auto w adjacency v with draw arrow, which is going to be our function that we'll have down here. Graph lines, positions v, positions w, which will be indicating for 2 different vertices as well. Hence we have this w right here with respect to adjacency of the vertices inside the adjacency list, because we need to connect 2 vertices with an edge to be able to make a graph. And then we're going to have this 4 constant auto and line with graph lines, count line and L, so we know exactly when we are rendering the following graph. And this is just the real kicker that will help us define how the graph is going to be laid out. Now we're going to draw the arrows, and whenever we have arrows in a graph, it is considered a directed graph. So technically you can combine both of these terms together and say we have a directed unweighted graph, because we don't have any weights inside of our edges. And so void draw arrow, we're going to have vector of string and graph lines pairing each integer here from, and then pair int to, so we can connect, know where to connect each vertex. Constant right here. Int x1 is going to be from first, y1 is going to be equal from second, there we go. And then we will have int x2 equal to first, and then y2 is going to be equal to second. So we know exactly when to pair each vertex with the respective vertex as well, and then draw the arrow. Then we're going to have our distance, dx equals absolute value of x2 minus x1 with dy is equal to the absolute value of y2 minus y1. Int s of x is equal to, as you have your semicolons that we set up in place, x of 1 less than x of 2, or 1 to negative 1. And then int s of y is equal to y1 less than y2, or 1, negative 1 in this case, and then error dx minus dy with the respective exact point. And while everything is already lined up and we have already rendered our graph, what we are going to be doing is determining where to actually draw the arrow, as in the line, and then the actual arrow point. So if x of 1, and so this is where we have our edge cases, so if they're in the same distance, and y of 1 is equal to y of 2, we're going to break int e2 is equal to error times 2 if e2 is greater than negative dy. We are going to implement, we're going to declare error to be decremented by the distance of y, and then we're going to have x of 1 be the be s of x. Then if 2 is less than d of x, error d of x, y1, sy. And then if x of 1 doesn't equal x of 2, or y of 1 doesn't equal y of 2, we're going to have our graph lines with the following parameters of y of 1 and x1 times 2 equal the following arrow dash, and then we're going to have our graph lines with respect to y2, and then x of 2 times 2 equal the actual arrow that we have. And yes, so this is our unweighted graph header file that we will be implementing while we are building out the necessary tasks for our graph, where we need to add an edge, remove a vertex, remove an edge, perform depth first search, and perform breadth first search both iteratively and recursively. So then, moving over here, let me just make sure everything's already built correctly. All right, build succeeded. Now, let's head over and use our header file to then complete the necessary tasks to build out our unweighted graph and the necessary tasks that we need to do. So let's move over to that. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you do have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.